Alright, in this section we are going to learn about scale drawings and models. A scale drawing or scale model is used to represent an object that is too large or too small to be drawn or built at actual size. The lengths and widths of objects on a scale drawing or model are proportional to the lengths and widths of the actual object. The scale is determined by the ratio of a given length on the drawing or model to its corresponding length on the actual object. Scales are written so that a unit length on the drawing or model is listed first. For example, you could have a scale of 1 inch equals 3 feet. This would tell you that 1 inch in the drawing or model is equal to a distance of 3 feet on the actual object. Or a scale of 1 centimeter equals 50 miles would tell you that 1 centimeter on the drawing or model is equal to a distance of 50 miles on the actual object. So notice that these have to be unit lengths first. So this is 1 inch, 1 centimeter. It has to be a unit, one single unit, whatever that measurement is, inches, centimeters, whatever. If the scale drawing and model have the same units of measure, the scale can be written without units. This is called the scale factor. For example, if we have the scale of 1 inch equals 2 feet, we can write that as since this is basically a ratio, we can write this as a fraction. So 1 inch over 2 feet. And then if we want to change this so that they have the same units of measure, we'll just change the 2 feet so that it's in inches. So 1 inch over 2 feet, well, if there's 12 feet in each inch, 2 feet would be 24 inches. And now we see that we have the same units of measure. We have inches and inches. So then we can just write this as 1 over 24. Or we could say the scale factor is 1 to 24. Now what does this mean? Well, because these units are in the same measure, the same units of measure, we can say that 1 unit on the model represents an actual distance of 24 units, no matter what those units are. Inches, feet, miles, whatever. The model, we could also say that the model is 1/24th the size of the actual object. So that's where that fraction comes in, that 1/24th. Okay, so let's take a look at some examples. The first one says a model car is 4 inches long. The actual car is 12 feet long. What is the scale of the model? Okay, so the model is 4 inches. The actual car is 12 feet. What we can do with this is set this up as a proportion, because what we really want to know is what the scale will be for 1 inch in the model. So remember, we want it to be written so that we have a unit length listed first. So 1 inch on the model is equal to 3 feet. 1 centimeter in the model is equal to 50 miles. So we want to know, to write our scale correctly, we want to know what 1 inch on the model is equal to. Well, since we don't know, that'll be x feet. And then we'll use cross products just like we did in the last section to go ahead and solve this for x. So we'll multiply those two, and we get 4x. And multiply these two, and we get 12. And then we will divide both sides by 4. And we should get that x is equal to 3. So what is the scale of the model? Well, 1 inch in the model is equal to 3 feet in the actual car. So that is the scale of the model. Now we could also take this and change it to a scale factor so that the units are the same measure if we wanted to, we would just change this 3 feet to 36 inches. So we would have a scale of 1 to 36. Okay, so go ahead and give the first try it yourself problem a try, and pause the recording, and when you're finished working that problem, press play to check your answer. Okay, and for this one, the scale that you should have gotten should be 1 inch is equal to 3.4 feet. Okay, since the dimensions of scale drawings and scale models are proportional to those of the actual object, we can set up and solve proportions to find unknown measurements. So in these problems, we won't be looking for the scale, but we will be looking for some unknown length that we don't know. So in example 2, a map has a scale of 1 inch equals 8 miles. 2 towns are 3.25 inches apart on the map. What is the actual distance between the 2 towns? Okay, so when we set this up, we know that the scale is that 1 inch is equal to 8 miles. Well, we want to know if the 2 towns are 3.25 inches apart, so we want to know what 3.25 inches is equal to in miles. And notice again that I've written the units as part of the proportion so that I can make sure that everything is matched up correctly. 1 inch and 8 miles is the scale, and then across from inches I have the other measurement in inches, and across from miles I have the other measurement in miles. It's always good to double check to make sure that you've set those up correctly. So now let's cross multiply. Got our cross products here. 1 times x is just x. And then multiply here. And 8 times 3.25 is 26. So if we could do anything else to solve this, we would, but this one comes out very nicely. When we cross multiply, we just end up with x. So x is equal to 26. So the actual distance would be 26 miles. Okay. So go ahead and do the next try it yourself problem. Pause the video, and when you're done working that problem, press play to check your answer. Okay, and for this one, the width of the actual exhibit room, you should have gotten 58 feet. Okay, let's continue on to section 6-7. We're going to talk about similar figures. So similar figures are figures that have the same shape, but not necessarily the same size. If 2 figures are similar, then their corresponding angles are congruent, and that just means they have the same measure. So you see that in this figure marked with the little red marks here. So angle A is congruent to angle X, angle B is congruent to angle Y, and angle C is congruent to angle Z. It's also true that if the figures are similar, their corresponding sides are proportional. So AB over XY is equal to BC over YZ, and that's also equal to AC over XZ. Now, we never set up proportions with 3 parts, but this is just showing you that any 2 of these parts together is true. So any 2 of those parts will be equal. So it will depend on which side lengths you're given and which side lengths you're looking for, but any 2 of these 3 ratios will always be equal when the figures are similar. And this statement right here is what shows that the 2 triangles are similar in this figure. This says that triangle ABC is similar to, that's what that symbol means, is similar to triangle XYZ. One thing that you can also get just from this single statement, you can tell which parts are corresponding parts. So even without having these figures here, I could tell you that angle A has to be congruent to angle X because they're in the same position in the name. So naming this triangle ABC is not the same as naming it, for example, triangle BCA, because the order changes. So your order here has to match the order there. So some of these you may not be given a picture for. You may have to draw a picture. Just make sure that your letters, the order that you match the letters up in this one when you draw a picture matches the order that you use for this one, because that is very, very important. Alright, let's look at our first example. It says the figures are similar, find each missing measure. So because we know that the sides are proportional, we can set up proportions to find missing lengths in similar figures. So we just have to make sure we pair up sides that are corresponding. So I see one side here in the small figure is 5 meters. And then I see the side that corresponds to it in the big triangle is 10 meters. So 5 meters over 10 meters. And now back to the small triangle. I see that this side is 7 meters. And then the side that goes with it in the big triangle is X meters. Alright, and we'll use cross products again to solve this proportion. So we multiply here, 5 times X is 5X. And we multiply here, 7 times 10 is 70. And from there we will divide by 5. And we get that X is equal to 14 meters. Okay, we're going to set up example B the same way. So you look at the corresponding sides that we have, we just have to make sure they pair up correctly. So the short side here is 3 inches, over the short side here, 15 inches. 3 inches, 15 inches. And then the long side in the small figure is 7 inches, the long side in the big figure is X inches. So 7 inches over X inches. Alright, and then we will cross multiply. 3 times X is 3X. And cross multiply again. And 15 times 7 is 105. Alright, and to solve this for X, we'll divide both sides by 3. And we'll get that X is equal to 35. And our units are in inches. So this is 35 inches. Okay, so just below this, there are two try-it-yourself problems. So go ahead and pause the video, work through those two problems. You're just finding the missing measure. And then when you're ready to check your answer, go ahead and hit play again to see if you got it right. Okay, for the first one, you should be getting that G is equal to 12 meters. And for the second one, X is equal to 66 meters. Okay. You can also find missing lengths in similar figures by finding the scale factors. We just talked about scale factor in lesson 6.6. Just like the scale factor is the ratio of a length on a scale drawing to the corresponding length on the real object, it is also the ratio of corresponding sides in similar figures. The scale factor is the constant of proportionality, and we talked about this a few lessons back, the constant of proportionality. We saw that when we looked at tables, and we wanted to determine if a table represented something that was proportional or not. And we found that by constantly dividing one table entry by the other one to see if the ratio was the same every time. And if it was, we called that a constant of proportionality. So remember that we can describe a proportional relationship using the equation y equals kx, where k is the constant of proportionality. So this just gives you an additional method that you could use to solve problems. And sometimes finding the scale factor actually will be necessary. So I don't think that you can just use one method all the time. Sometimes you will actually need to find the scale factor. So a good way to remember this for the scale factor when you're talking about similar figures, the scale factor is always equal to the new over the original. Now, when we're talking about similar figures, sometimes it won't be obvious which one's new and which one's the original. So think of the new figure as the one that you do not know the length of. You're trying to find the length of that one. So that will be the new figure. Alright, so let's see what this looks like on example number 2. And we'll solve this both ways so that you can see kind of the similarities and the differences between using the proportions method versus using the scale factor method. So example 2 says, nested boxes are a series of boxes that fit inside each other. The faces of the boxes are similar rectangles. A face on a larger box has a length of 24 centimeters and a width of 13.5 centimeters. If the width of a face on a smaller box is 9 centimeters, what is the length of the smaller box? Okay, so method 1 is just like what we would have done on the previous page. So we would first look at the two figures that we have and look at what lengths correspond. So we have a face on a larger box has a length of 24 centimeters and a width of 13.5 centimeters. So let's make sure we group the lengths together and also that we group the widths together. So for the larger box, the length is 24 centimeters and the width is 13.5 centimeters. Okay, so again, I've made sure everything's lined up. I'm putting length in the left and width in the right, and the top is both dimensions from the larger box. Now our other information says if the width of a face on a smaller box is 9 centimeters, what is the length of the smaller box? Now again, we have to make sure that this 9 centimeters goes in the correct place. It is the width, so it needs to go in the same place as the width of the larger box. So 9 centimeters. And we want to know what is the length. Okay, so then we'll go ahead and use our cross products again. So x times 13.5 is 13.5x. And then 9 times 24 is 216. And then we'll divide both sides by 13.5. X is equal to 16. And our units are in centimeters, so this will also be in centimeters. Okay, now our second method would be to actually find the scale factor. So remember, for scale factor, we want the new one over the original. So in this case, remember, think of the new as the one that you're trying to find. So what we're trying to find here is the length of the smaller box. So we want the small one over the large one. And we have to use, of course, the lengths that we're given. So if we don't know the length of the smaller box, then we're not going to use the length of the larger box, because those lengths would go together and we don't know one of them. So we have to use the widths. So the width of the larger box is 13.5. That'll go on the bottom. And the width of the smaller box is 9. So 9 over 13.5. Okay. Now, when you divide these, you'll see on the calculator that it gives you a repeating decimal. You get 0.66666, and then of course the calculator rounds it off to 7 at the end. But we really don't want that as a repeating decimal. We can't really do any calculations or computations with a repeating decimal. So we're going to want to leave that as a fraction in simplest form. So hopefully we remember this one just because it's a common repeating decimal. But that 0.66666 repeating, that is just equal to 2/3. Okay, so our scale factor is 2/3. Alright, now our general equation is y equals kx, where k is the constant of proportionality, or in this case, the scale factor. So the y will always be the one that you are trying to find. So we're looking for the length of the smaller box. So that is the length of the smaller box. And I can say that's equal to the constant proportionality, which is the scale factor, 2/3, times x. So in this case, x is the length of the larger box. Okay, so the length of the small box we don't know. We'll just call that L. And that's equal to 2/3 times the length of the large box, which is 24 centimeters. And if we multiply 2/3 times 24, you should get 16 centimeters. The exact same answer we got over here with method 1. Get the same thing using method 2. Okay. So on the try it yourself problem, you don't have to use both methods, but it might not be a bad idea just to make sure you get the same answer both ways, and also just to make sure that you can actually work with the scale factor method, because there will be some problems where you need to understand scale factor and you need to be able to use it correctly. So go ahead and pause the video, work out try it yourself 2A, and when you are ready, go ahead and hit play again so that you can check your answer. Alright, and for this one, the width of the red tile, you should have gotten 20.25 inches.